Hi dear students, we are starting with the next geometry session that is based on very much important topic, that is circle. Today what we will do is we are going to cover up all the important theorems, all important properties through circle, and in the next session we are going to do some difficult sums based on these properties. In fact, as you know that these theorems were there in 9th standard, but definitely it is of some use this year also. This is the center of the circle, that is O. Now if I draw a chord here, then this is chord AB, and if I draw the perpendicular on that, which is OM, so I write here segment OM is perpendicular to chord AB, and when you drop the perpendicular on chord AB, that bisects the chord. So ultimately what happens, AM is becoming congruent with MB. So if you drop the perpendicular on the chord, if AB is of length 10 centimeter, then each one AM and MB will be each of 5 centimeter length. So AM is equal to MB will be 5 if AB is 10. Now this is a general rule which we are going to have somewhere while doing some questions in circle. Now there is one more property. This is what we have discussed about. Property number 1. Whenever you drop the perpendicular on the chord, it bisects the chord. So it is better that I write 1 upon 2 times of AB. Now there is one more property, the converse of that. Now what I will do, if I join this particular part, if I consider that M is a midpoint, so I write this property, line joining the center, line joining the center of circle and midpoint of the chord, line joining the center of the circle and midpoint of the chord is perpendicular to the chord. Line joining the center of the circle and midpoint of the chord is perpendicular to the chord. So remember thing like this. If you drop the perpendicular on the chord, it bisects the chord. That is a theorem, and the converse will be, if you join the center of the circle with the midpoint of the chord, then it is going to be perpendicular to the chord. These are the two main properties what you have studied in your 9th standard. Actually, while doing some questions here in circle topic, we require to take help of these theorems. Again I repeat, perpendicular from the center on the chord bisects this chord. And one more thing, line joining the center of the circle and midpoint of the chord is perpendicular to that chord. That is a converse of this. I hope this is very much clear to you. Let us go for two more properties here. The center of the circle I marked as O. This is one chord which I consider that chord as of AB, and there is one more chord which I have drawn, that chord is CD. Now I write here, these chords are congruent chords. So chord AB is congruent to chord CD. Now if I ask you that find the distance of each chord from the center. So distance of a chord from the center is definitely going to be perpendicular distance of the chord from that center. So I have to drop the perpendicular here and I have to drop the perpendicular here also. If I consider that as OM and this is ON, and if you measure these distances, then these distances are going to be equal. So this is my first property here. If chord AB and chord CD are congruent, then segment OM is congruent to segment ON. Now the reverse of that. Suppose there are two chords of the circle which are equidistant from the center. That means we can write that part is a reverse way. Segment OM, if suppose it is congruent with segment ON, then the chord of length AB and chord of length CD are equal. That means we are going to write chord AB is congruent to chord CD. In very simple language, it's very very clear cut statement. What we can say like this, that congruent chords are equidistant from the center. What you have to say like this, congruent chords are equidistant from the center. And what will be the converse of this? The converse is, if the chords of the same circle are equidistant from the center, then they are congruent. Actually, both the theorems were there in your 9th standard. Why I am repeating it? Because definitely it is of some use while solving few sums in the textbook. Remember one thing, congruent chords. See the sequence which I have written. First we have written chord and then we have written about the distances. So we have to say congruent chords of the same circle are equidistant from the center. Equidistant, that means at equal distance. OM and ON are equal. Reverse of that is what we call it as converse in geometry. The converse is, if the chords are equidistant from the center, then the chords are congruent. But don't forget to use the word chords of same circle. Correct? So here I make a statement, congruent chords of the same circle are equidistant from the center. And here I do like this, if two chords of the same circle are equidistant from the center, chords are congruent. I hope this is the fourth property we have finished. I hope you have understood this part, because even if the theorems are not asked on these things in 10th standard, actually this is the thing which is basic thing required for proper analysis of some difficult sums. Let us discuss about the main important part or a theorem of this year. This is what I say, that alternate year they ask you this proof. This is the center of the circle and there is one point P which is taken outside the circle. This is a center O there. Now there is some terminology used that is called as tangent to the circle. Now tangent is nothing but whatever the line you observe here which is touching the circle. So this one is called as a tangent, that is point A for example, this is called as point of contact. Now what you have to do is, you cannot have only one tangent on this side. There is one more possibility, that the tangent is drawn like this. So this is the point of contact. So how many tangents you can draw from the external point? From the external point you can draw two tangents to the circle. And these tangents are congruent, that is what you have to prove. Now I'm not writing the entire proof here, that you can easily manage through your basics. But see what you have to write. This is the diagram what you are supposed to draw first. Tangents drawn from the external point to the circle are congruent. Now if you want to prove, now what is the statement to prove here? We have to prove that PA is equal to PB. That is what you have to prove. But now this is the part of two triangles. Now you don't observe any triangle here, and that's why there is need to do the construction. Construction is dotted. So we have to join this OP. Then we have to join this OA. Then we are supposed to join this. So we have drawn these two triangles. Now these triangles we have to prove congruent by some test. Now as you know that this particular angle is 90, this is going to be also 90 degrees. The reason that you are going to write here is tangent, radius, perpendicularity, tangent, radius, perpendicularity theorem. Tangent, radius, perpendicularity theorem. That means the angle between the tangent and radius at the point of contact is 90 degrees. Now what we can say about this? These two distances are congruent. These two distances are what? Congruent. Because they are representing radii of same circle. And there is one common line you observe in between. That is OP. OP is a common segment between the two triangles. So we have to use this particular property, and remember one more thing that is better for many questions henceforth. Whenever you are writing something about the triangle which is right angle triangle, you have to take center as 90 degrees. That is triangle OAP. Triangle OAP is congruent to triangle OBP. The reason what you are going to write here is hypotenuse. This is the common line there. So that is the hypotenuse of both right angle triangles, and therefore these triangles are congruent by hypotenuse side test of congruency. The triangles are going to be congruent by hypotenuse side test. Now this is what you are going to come across in alternate paper almost. Roughly I am saying, it is not the rule in fact, but this is the most important theorem which they normally ask you for 3 marks. What is that? Tangents drawn from the external point to the circle are congruent. I am going to take 1 or 2 difficult sums based on this particular property, which may be probably asked in your exam. I hope this theorem you have already done it, but things are very much clear to you now. Okay, let us go for one more important topic related with circle only. One is, I write here, inscribed angle. I will explain you all the terms one by one. Then it is called as inscribed arc. Then it is called as intercepted arc. Intercepted arc. Now here I draw this. There is one point A I have taken, and these two markings are done. Now this is the angle which I have drawn there. Now that angle is called as angle BAC. Now you imagine that you are standing at A on the circumference and you stretch your both hands. Then your one hand is going to be AB and the other hand as AC. You are standing here and you are stretching your two hands. One is AB and other is AC. So whatever angle you are standing, that angle is known as inscribed angle. Is that clear to you? Now, in that, with respect to that inscribed angle, if you are observing an arc which is in front of you, that is RBXC. So that is called as intercepted arc. And now the arc which is behind you, that is this arc BAC. That is what we call it as inscribed arc. Again I repeat, many students they confuse in between like this. What you have to do is, we have to consider the point on the circumference. Now if you are standing here, you are having two hands stretched like this. One is AB and other is AC. So what you observe in front of you, that is known as intercepted arc, and what is behind you on the circumference, this arc left, is called as inscribed arc. So we make a clear-cut statement like this: angle BAC is inscribed in arc. Angle BAC is inscribed in arc BAC, and it intercepts an arc. Intercepts means you have to see above, see in front of you, that is BXC. So whatever arc is behind you, that is called as inscribed arc. Whatever is in front of you, that is called as an intercepted arc. And the place where you are standing, that angle is known as inscribed angle. Now there is certain relation between the inscribed angle, then intercepted arc. Major angle. Now this angle is called as inscribed angle. That is why we say BAC. So angle BAC is congruent to or is equal to 1/2 times of major arc BXC or not. Again I repeat, major angle BAC is inscribed angle. The measurement of that angle will be always half of the arc which is facing it. So it is half of BXC. Now deal with that. Now there is one center which we have not shown, but now I am showing it here, that is point O. Now if I join this point with the center, this point with B and C like this, then whatever the angle is formed, that angle is formed at the center of the circle, and therefore that angle is called as central angle. That angle is known as central angle, and the measurement of angle BOC is not the half now, it is same as major arc BXC. Remember one more thing, this angle is not having a placement on the circumference. This is angle formed at the center. That angle BOC is called as central angle, and the measurement of the central angle is the same as measurement of corresponding minor arc. But when it comes to the angle on the circumference, this angle BAC is formed on the circumference. That angle will be half of the arc which is facing it. So angle BAC is half of angle arc, half of this arc BXC. Remember one thing, measurement of arcs are given in terms of degrees. So whatever answers you are going to have here in this case, they are all in degrees, not in centimeter. Measurement I am taking it, not a length. Length of the arc is different. I am talking about measurement of the angle and measurement of the arc, not the length. So measurement of arc, measurement of angle, they are all expressed in degrees. So this is coming under the heading inscribed angle theorem. What is the statement of that? Measurement of an inscribed angle will be half the measurement of corresponding intercepted arc. I hope this particular theorem is clear to you, because one question on this theorem is 100% asked in boards. So you please focus on this particular property. This is coming under the heading inscribed angle theorem. There are 3-4 theorems which are related with this. So I will discuss that later on. This is one of the basic theorem. We'll go ahead with one more proof which can be possibly asked in the exam. I'm writing that statement over here. Angles inscribed in the same arc. Angles inscribed in the same arc are congruent. Angles inscribed in the same arc are congruent. Now, I'll just explain you what do you mean by that, angles inscribed in the same arc. What is that meaning? Suppose I talk about angle A, B and C. Now this angle is what we call it as inscribed angle, and that angle is over here, correct? Now when you talk about the inscribed angle, immediately in front of this you have to see the arc which is AXC. So when you see the figure like this, then ABC is an inscribed angle and it is going to have this as an intercepted arc. So what is the inscribed arc? Inscribed arc is ABC only. Angle ABC is inscribed in ABC arc and it intercepts AXC. That is the meaning of that. There is one more angle I will take now. Suppose I mark the angle like this. This is D point. This is the arc. Now what I say here, angle ADC is also inscribed in the same arc. Because if you see the intercepted arc, it is same AXC. So whatever arc you are talking about which is behind that angle is called as an inscribed arc. So here I can say angle ABC and angle ADC are inscribed in the same arc. Therefore, they are going to intercept the same arc. Therefore, they are congruent. Now, how to write the proof? In the exam, you should also write it like this. Measure angle ABC. That is going to be half of measure arc AXC. Correct? Second statement. Measure angle ADC is 1 upon 2 times of measure arc AXC, correct? Both the statements, they are having the same right hand side. Reason is same. What is the reason? Inscribed angle theorem. Both the statements, they are having the same right hand side. Therefore, left hand sides are equated. Therefore, ABC is equal to ADC. And therefore, the next statement we can very well write, angle ABC is congruent to angle ADC. Correct? And therefore, what we have, ABC is congruent with ADC. These are angles which are inscribed in the same arc. We have to focus on these properties because This is not the important thing only as far as the theorem is concerned, but while solving few sums which are of 3-4 marks, you require in between these properties to be applicable. You have to implement these rules there. So there is direct connection of these particular theorems for the proofs. I hope you must have understood this properly. Let us discuss about one more theorem which is asked in the boards, that is called as about a cyclic quadrilateral. When you have a quadrilateral whose all vertices lying on the circumference, that is having a specific name, that is known as cyclic quadrilateral. Now the rule for this proof is, whatever the property you are supposed to know, opposite angles of cyclic quadrilateral, opposite angles of cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. Now what do you mean by that? This angle, major angle ABC, is one angle. Now if you see the angle which is opposite to it, that is this, no? So we have to write major angle ADC are opposite angles of cyclic quadrilateral and they are supplementary, means the addition is 180. Is it clear to you? I think there is one more pair, that is major angle. Now if I take DAB, major angle DAB plus opposite to it is DCB, so major angle DCB, that is equal to 180 degrees. So there is one more pair. Now remember one thing, that one theorem, that is what I discussed in the beginning, that is tangents drawn from the external point to the circle are congruent, and this one, opposite angles of cyclic quadrilateral supplementary, they are asked one by one. This is my normal guesswork, that suppose in earlier year they have asked this, then this year there is a chance that you are going to get the theorem of external points, tangents are drawn to the circle are congruent, and vice versa. So you please focus on these two theorems as far as 3 marks question is concerned on circle theorems. One more important proof related with this circle and cyclic quadrilateral again. This is the cyclic quadrilateral A, B, C, D I have marked. Now what I have to do is, I have to extend one of the sides here, and that is going to be point E. Now you are knowing this already, again we will revise. See, whenever you extend one side, then whatever the angle formed is called as an exterior angle. Now in case of triangle we say exterior angle of triangle. Here we have to say it is an exterior angle of cyclic quadrilateral. That angle is congruent to the angle opposite to its adjacent interior angle. Now you focus on this. This is the angle what we call it as exterior angle. So adjacent interior angle is this, and angle opposite to this is this angle. So what it means, that these two angles are congruent. What is that? Major, or we can say angle CBE. This is what we have to say, that this is called as exterior angle of a triangle is congruent to the angle opposite to its adjacent interior angle. This is the adjacent interior angle and opposite to it means this. So we can write that angle is ADC. This is one more property which you frequently require for proofs. Theorem will not be definitely asked, but a question of 1 mark can be asked here. Suppose they say that this measurement is, for example, 95 degrees, then they will ask you this measurement. Many students, what they do, they are calculating this angle because they are in a linear pair. Then they are using a property that opposite angles are supplementary. Then they find out this. But for that calculation, you require two steps. Here, we can make use of the thing directly. That this angle is angle opposite to it, adjacent interior angle. So, exterior angle of a cyclic quadrilateral is equal to the angle opposite to its adjacent interior angle. This is the way we have to mark. Are you getting it? I hope this particular thing is clear to you. This is related with exterior angle of cyclic quadrilateral. We will discuss one more theorem now. Now we are having this is what we call it as tangent, and this one is called as secant. Now this angle I marked as angle ABC. So this angle is formed between tangent and secant. So there is a proof. Actually that is not asked in the exam definitely, but we need to learn this. That is tangent secant theorem. As the angle between tangent and secant, that angle is major angle ABC. The property looks like a inscribed angle theorem. Inscribed angle theorem will be what? Inscribed angle is half the intercepted arc. Here the angle between tangent and secant, that is going to be half of the arc which is included between this. That is half of major arc AXB. This is known as tangent secant theorem. Now there is one more connected thing after that, which will be required in construction topic, and even in this chapter. This is point D. So when you talk about this ADC or ADB angle, again I repeat, this point D is giving you one more angle, that is major angle ADB. That is equal to 1 upon 2 times of major arc AXB. See, one more thing, I will clear it now. This angle is angle formed between tangent and secant. So by using tangent secant theorem, major angle ABC will be half of AXB arc. Similarly, angle ADB is formed on the circumference, and both these arms are lying in the interior of a circle. That is why we call it as inscribed angle. That inscribed angle is half of AXB. Now if you see the right hand sides, they are same. Therefore we say that angle ABC is equal to major angle ADB. Now how this thing is explained in the textbook, I will mark it now. This angle, whatever is formed, that angle is formed in, this is what portion, whatever I highlighted, that is known as, this portion is known as minor segment. What it is? It is known as minor segment. Now this particular angle is formed in this region. So I highlight this part now. This region, whatever is formed, that region is adjacent to this portion, that is known as major segment. Is that clear to you? And therefore, there is a proof which is given a reason. Now these angles are treated in that way. In the exam, you are not going to prove this. That is having a direct result. This angle is in a minor segment and this angle is called as angle in a major segment. And if there is a minor segment, immediately after that there will not be minor, there will be a major segment. And you consider this as a major, then immediately after that minor will come. And that's why this result you can directly write in the exam stating the reason angles in, it is known as angles in alternate segments. What is this? Angles in alternate segments. I hope this is clear to you. We are starting with the next part of this, that is about these two chords. This is chord AB and this one is chord CD. These chords are intersecting each other at point P. Now I am giving you two results over there. You need not do any theorem related with this, but properties are definitely important because these are the questions normally asked for 2 marks. I am writing over here property of. Here I am writing word internal. Property of internal division of chords. Property of internal division of chords. Now why we call it as internal division? Because two chords of the same circle, they are intersecting each other inside the circle. This is point P. So what they ask you this angle. See, there are two properties. One is related with the length and one is related with the angle. Both the things are having the same reason. Now, suppose they ask you this measurement. I write the theorem statement here. Measure angle DPB. That is equal to. This particular angle is going to be half of. Here we have to write down the reason. And that reason is similar to the inscribed angle. Now you tell me, if this is the angle taken into consideration, then what will be the arc which is facing it? Is this arc or not? So here we have to write major arc DB plus. Now just see opposite to it. This arc is on the back side. So here we have to write major arc AC. Is that clear to you? The angle which is formed because of the intersecting chords inside the circle, that measurement of the angle will be given by the formula like this. This is what I told you, that this particular property is related with the measurement of the angle. But there is definitely one more property, that is starting with this P. Now what you have to do is, we have to write PA multiplied by PB. So point of intersection is P, so we have to take two parts and multiply. That product will be equal to PC multiplied by PD. Remember one thing, you are supposed to start with P. PA multiplied by PB, that is what PC multiplied by PD. You can work on this. These are the two things. If suppose they ask you about the angle, then we have to use this formula. Suppose they give you 3 lengths out of these 4, then finding out the fourth will be calculated by this one. This is related with the length. Is that clear to you? They have not used this word, but basically when you write this particular property, you please write down the reason as property of internal division of chords. I hope this is clear to you. And the last one now for this one, there are two chords like this. Now actually this is not the chord is AB and another chord is CD. This chord AB and CD are the chords of the same circle in such a way that they are not intersecting each other inside the circle. So for that matter you have to extend it. So that is going to form this particular figure. So therefore, if you are coming across this kind of figure, we have to use this logic or this theorem statement. We have to write property of external division of chords. Now, they ask you first of all this angle. So I am writing the name of that as major angle APC is equal to 1 upon 2 times of. Now in front of this angle, if you observe, there will be two arcs. One which is very close to you, definitely it is smaller, and one which is away from you, that is bigger. So it is external division of chords. So there will be minus sign. So out of this, the bigger arc you have to write first, that is major arc BD minus major arc AC. Remember this property properly. The angle formed, which is because of the external division of chords, that will be calculated by using this formula. Now we have to write something about the distances. So that distance is same as the earlier one. But remember the logic, PA multiplied by not AB, PA come back to the original point and then go to the last. So PA into PB is equal to, it is PC multiplied by, here we have not going to write CD now. Once you complete distance PC, then come back to point P and then go to the point D. So this is a rule which we have to write. PA multiplied by PB, then it is PC multiplied by PD. Are you getting it? This is the way we have to complete this. These are all the things which I have just explained you. But you have to practice more sums where all these questions, all these properties are coming together. That analysis you need to work on so that the attempt of this circle topic will be easier in boards. I hope this is clear to you. We will take one more connected thing here. In the just before this, we have taken property of internal division of chords. Then we have seen property of external division of chords. Now we are having tangent segment theorem. Now what do you mean by this? This theorem is not going to be there, but it is having just property applicable. For example, I have drawn this point P here. I have drawn one tangent here. This is a point of contact. And if I join this, now what is the meaning of this? I have drawn the figure like this, but actually initially the chord is there. That chord and this tangent, they intersect outside. Now there is a property like this. Now what I told you regarding this in the earlier proof, it is PA, come back to P and then go towards B. That's why it is PA multiplied by PB. It is never PA multiplied by AB. It is what? PA multiplied by PB. And what you can do here in the same reference, PT multiplied by, again you come back and again you go there, but there is no second point. So again you have to say PT. So tangent square. So here the result is totally different. PT square is equal to PA into PB. That is what the rule is. That is having a reason. tangent segment theorem. See, whatever we have discussed in this session, there are two important theorems which are asked alternate year in boards, but rest of the themes, or what we can say, these are all basic statements. They are all important while solving the sums from the textbook. So if you know these properties very well, then circle topic will be easier to follow. I hope you must have covered or you have listed it. For the final board exam, all these properties along with some theorems which I have told you, they are all important. Okay.